Hello, my name is Kevin. In a previous video on cable selection, I made some remarks in consideration to alternatives to PVC. In this little video, we look at some of the ways we can mitigate the actual reasoning behind and continued use of such cable. Okay, so in today's power engineering conundrum, we're looking at special insulation and the cable selection and how we can utilize that in our daily approach. So as I mentioned in our previous cable selection video, I made reference to the concerns I had with a circuit breaker, multi-case circuit breaker, miniature circuit breaker, getting changed in its characteristics by the use of non-PVC cables. Now, there are some areas of our electrical engineering industry where we actually use quite a lot of these type of cables. And I don't think we're doing it badly at present, but there are a number of things which we'll discuss. So if we look specifically now at the droppers from busbars in a DB to the breakers, we traditionally have three popular choices. We can have a solid copper conductor dropping down, much the same as the bigger busbars, the smaller ones on the feeder sizes going out to and connecting to the top of the circuit breaker. We could have flexible copper conductors, and this is really what I'm looking at in this sort of topic here. The others are just by the by. And of course, you do get bare flexible braided copper conductors, copper pigtail type conductors. And the relevance here is also that they should be treated with the concern that we do with the normal solid conductors. So when we have a look at solid busbars and even the braided copper, they don't have insulation generally as they come out. And when we look at their density of current reaching certain temperatures, which is their full rating, of course, there's no allowance made because they do not have any insulation that could get damaged. They're in straight air and they will be qualified typically something like 105 or maybe 125 degrees Celsius. They carry a certain rating. Now, of course, we know from the circuit breakers that we are talking about 70 degrees PVC wire. And that variation here will have a negative effect on the breakers that will be connected to these type of products. And very often, you see what the guys do is they use these bare conductors and then they heat shrink sleeve them and to identify them with colors, red, white, and blue, black for neutral maybe. And they put that and shrink that directly on top of the PVC. Now, there's obviously no understanding the fact that you've got a piece of bare copper which could reach 105, 125 degrees maybe, and we're going to go and put 70% PVC on, which is 70 degrees compliant. So this is very problematic, and obviously the user that does that is not really au fait with covering it with that type of stuff. Now, I know you do get other types of insulation. I've probably yet to see them in the real world on some site. So you can see all over town when you go and have a look at any of the major panel boards I've ever seen, over some time, the PVC splits and discolors, and the tape sort of unwinds, loses its adhesion on there. And of course, the temperature in the DB may also be somewhat of a problem. By having hot running conductors in there, you add to the heat within the DB, and that in itself may be somewhat of a problem. The flexible insulated cables, and as I said, this is really the topic where we're coming from today. In the main, these are either rubber or rubber type, nitrile rubber types, and silicone type compounds used in the insulation. And of course, that means they are quite far above, again, the PVC type. Rubber types maybe at 95, starting somewhere. That silicone far higher and becoming much more prominent these days in availability of silicone, which used to be very expensive. I think you're starting to see these type of cables a lot easier. And again, the main problem here is these temperatures could have a negative effect on breakers that they are connected to. They too will obviously discolor. They will have color like red, white, and blue as a shrink, a PVC shrink put on them. And you see this as this almost a standard industry norm out there. And of course, you'll have the similar problems on the DBs with this type of cable. Now, what are the warning signs if you go to site and you see this type of thing? Is you're going to see you might be called in because there's breaker performance issues, tripping too soon, not carrying rated current, tripping at a certain time of the day. And that would be maybe possibly tracking the temperature ambient. So here, 1:30, 2 o'clock. In the hottest time of the day that the breaker starts to perform, like tripping out for no radical reason other than it just trips. You could have a seasonal type of thing where it performs all winter long with no problem. Then you get into summer, and the hotter the day, the more problematic these things happen, indicating that it's basically a thermal type of event. As I said before, you also get some contribution to your DB heat. Not a good idea to have your panel board running above, at least above 60 degrees, you will definitely have a problem. So every bit that you add in terms of a piece of conductor with a resistor, which contributes to the heat, and you lock that heat into a DB, you are going to have a problem with heat, specifically on thermal type breakers, obviously. If you have PVC on a lot of the stuff, on the conductors inside that panel, you will see that will dry out and split. Not a good idea over time that all your insulation starts to peel away and peel off. You sometimes see that the PVC browns, it starts to discolor. It's not really a burn as a fire, but over time it loses all its elastomers and becomes brown and looks as if it's taking a heating type readings. And of course, with all this going on, if you are doing infrared scans, you're going to get hot spots just based on this type of thing. So you're going to find your cables are decidedly hotter than or these devices that we're talking here today, solid busbar, braided busbar, and different insulation levels are at a different heat. So they will be hotter to the scans, and you're going to have a look at those with some concern. So let's have a look at some of the solutions, because obviously this is extremely widespread in the industry, and let's face it, it's the DB manufacturer that really carries this burden. It's not the guys going to site, unless you've got something really, really so radical that you have to change something to continue there. So, I mean, this is the intention here is not to just stop dead and don't use these things, because they're widely accepted. And let's face it, having insulated bus bars is a good idea. As well as the fact that they're quite flexible, so they do tend to root nice and neat and hang, and can be supported in supporting things within the panel against short circuits, high level short circuits. You could, as a potential, lower the current value, decrease the actual physical load on a product, rebalance loads, rebalance phases, maybe. That may be one of the ways, the easy way out, maybe. Parallel conductors, typically what we see is that people make the lugs stack on top of each other. Now, that's not a very good idea, because the heat then is on a very small area with a high current. So that in itself generates like a hot spot on the busbar. So even that is potentially a problem. If you're going to use parallel conductors, and sometimes it's much easier to put 2 or 3 or I've seen even 4 conductors in that arrangement, but then the stab that you connect to should ideally carry 1 termination per side, but you can have a bolt making both sides of a stab. But the idea is you don't just stack 4 cables through one connector surface area into the base. So that's one way. If you see that type of thing where it's multiply stacked, just moving them around and getting a better stab size at the bottom might remove the problem. So the main solution to the approach that I'm proposing is that whenever you use PVC covered version, you get a certain square millimeters of copper required. And if you take that square copper that you would do with PVC and you extrapolate across into the other types, that's in the busbar, in the braided type of busbar, and even in this type of thing, what will happen then is that that busbar and that cable, that PVC, it will act like a piece of PVC. So it will only get to 70 degrees, which is then in line with the performance of the breaker. So it's quite easy to fix this. It's not to say we don't use them, but what we would do here is that we would have a look at the square millimeters of that. So in PVC, if the criteria was 50 mil cable, and we've gone and used silicone cable, or we could use silicone cable for the same current, at 25, we know that's going to get much hotter. All we would have to do is make sure we use an equivalent copper square millimeter size that you would use with PVC cable, and we would have no problem. Then the temperatures would be there. So it's quite an easy thing to use. It's not, let's say, something that's out of this world, and there's not great things have done. It's a pure engineering type of function. Unfortunately, as we said, in many cases, it's in the manufacturing stage that this should have been done. And that would make quite a huge difference in the panel going out. So if you've got any more questions on this concept, drop me a line. Let's have a look at it. As I said, it's not rocket scientist. It's purely keeping the square copper. Remember also that a hot panel board is not a great thing to be in the world out there. It tends to do all sorts of things, like not only just the breakers, it's putting a lot of stress on all forms of that panel board, anything that's plastic, anything that's insulated within that. Over a period of time will become brittle, will become a problematic area. You don't really want to have excess heat in there. You would like to keep it as cool as functionally possible. Then you will have no problem. And with that, I say adieu.